All right, today we're going to be talking about decentralized PKI. So we'll cover what PKI looks like today, how that's changing, and what it looks like in all its different forms and flavors. So let's get started. All right, so you're probably asking what is decentralized PKI, and we'll get to that. But I think to start out, the best place is understanding how PKI is being leveraged within the organization. And really quickly, we can see that it's being used enterprise-wide. In fact, most organizations are using PKI to support about 11 different applications across the business. And that stat comes from a global encryption trends report from 2 years ago. So you can imagine it's probably grown quite a bit since then. But if we think about PKI and its traditional use case, initially leveraging SSL TLS certificates to secure public-facing assets like your web servers and your applications, so that your customers can trust you and visit your websites and transact with you. And then you started maybe using internal PKI, things like Microsoft ADCS or an internal CA to issue certificates for maybe use cases like user and device authentication or Wi-Fi authentication. But now when we look at PKI, there's been this resurgence of use cases really across the business into this DevOps and cloud realm. And that's really exploded. There's been quite a few different CAs and certificates being leveraged in those environments for things like containers and microservices architectures, things like ingress security with Kubernetes and service mesh as well. So we're really seeing quite a bit of exploration into these areas, and as a result, PKI has grown quite a bit. So that's really what's created what we call this decentralized PKI model, where it's being used by multiple different business units, really in this kind of ad hoc fashion, and we'll get into that in just a bit. But if we talk about kind of that growth a little bit more, we did a study earlier this year on the state of machine identity management with Ponymon. And really, we focused on all the different types of machine identities. So keys, certificates, secrets, things that are being used on machines to encrypt, authenticate, and secure those. And what we saw was the use cases that were driving that were primarily cloud-based services. And that should be, again, relatively unsurprising. A lot of organizations are making that move to the cloud. But the other component of that is zero trust, this idea of zero trust security or zero trust architecture. And identity plays a really core role in that, ensuring that you can authenticate these different machines and devices in your network, because now you've moved from this traditional castle and moat approach to a approach where you're assuming that the network's been breached. So now we've seen this rapid growth. 61% of IT and security pros that we interviewed said that they are growing certificates at a rate of 61%. So I imagine that's probably a lot higher. Maybe there was some self-denial there, but there's been a lot of growth in this area in terms of the use and deployment of certificates in these environments. And now when we think about where are those certificates coming from, it is the public key infrastructure that kind of sits behind that. And when we kind of continued that survey of those IT and security professionals, what we saw was that when we asked, what does your PKI deployment look like? It was really a mixed bag. So of course, you've got your internal privately rooted CA. A lot of organizations are, again, using Microsoft ADCS, things like auto-enrollment for their devices internally, and maybe even EGBCA. We've seen a lot of organizations are looking to alternatives to ADCS for better scalability and integration with their different use cases. So PrimeKey's EGBCA is a great example of that, where organizations are starting to leverage that. But what we also see is these kind of built-in issuing CAs, and maybe we wouldn't even really call them CAs, they're more issuers, because these are embedded within tools in a DevOps pipeline or a DevOps tool set. So think about HashiCorp Vault, for example, or Kubernetes secrets. And these are being used often outside of the scope of the security team. So DevOps teams are spinning up their own CAs or self-signed certificates and kind of moving as fast as they can. But the security team over here either doesn't have visibility into that or they're trying to take back control. And then when you look outside of that, you maybe even have private CAs that are running in a public cloud. So these are relatively new services. If you think about AWS private CA or Google Certificate Authority Service, and these are built into those cloud services, and a lot of organizations are leveraging those within those cloud environments. And even some organizations are leveraging externally hosted private CAs, so a managed PKI service that allows them to still get that capability of a robust internal CA, but without having to manage the infrastructure and the security around it. And we'll get into that in just a bit. But as you can see, we kind of go down this list. The scope of CAs that are being leveraged just grows and grows. And this is really where kind of decentralized PKI, that concept comes in. So you have this challenge of CA sprawl, where there really isn't a one-stop shop for certificates anymore. You have different teams that are deploying their own self-signed certificates or leveraging their own CAs, and oftentimes really without any centralized visibility or control over how those certificates are being issued or what the enrollment process is like, and what standards those certificates are supposed to meet. So if we talk about Gartner, they're seeing this too. So we talked to analysts there. Eric Wallstrom is one of those, David Motti another. Highly recommend that you have a conversation with them. They're really great at helping you evaluate the tools out there and understand where your gaps are. But this is really what's driving the use of different CAs. So trust requirements is one. So if you think about that at a very basic level, you have publicly trusted certs that you need for your external facing assets, and then your internal certificates, which are growing at a much more rapid rate. And then you have migration, things like migrating from on-prem to the cloud, and how is your internal PKI infrastructure going to support that? In many cases, it can't. And then even in the scope of migration is mergers and acquisitions. When you bring on new components to the business, they're likely leveraging their own public or private CAs that you now need to bring under that umbrella. And then those specialized use cases that we talked about earlier, things like DevOps and CI/CD pipelines, you need to ensure that the integrations and protocols are there that you can support those use cases. And then these hybrid environments, of course, as I mentioned, with those different CAs and trust chains, you may even have multiple different routes within your environment, say for devices that you're manufacturing that are being delivered to customers versus those certificates that are being used within your business. And then again, the lack of integrations with those different use cases that are often kind of in those traditional PKIs, they're not able to support those use cases anymore. So this is why teams are kind of moving to the usage of multiple PKI deployments and CA deployments. So now we're kind of left with this state of hybrid PKI, or what we sometimes call decentralized PKI. And again, it's a state where you're using multiple CAs. Auto-enrollment only goes so far to support your internal use cases. So you're really kind of exploring all these areas, and organizations need those different options out there, whether it's in the cloud or on-premise for traditional or modern use cases. So let's talk about the different types of certificate authorities and trust chains that make up a modern PKI deployment. And that really starts with your public CAs. This is something that most people are pretty familiar with. You probably have purchased and procured a certificate that, from a public CA like DigiCert or Entrust, for example, and issued that into your environment. And the common use cases for this are things like web servers and load balancers, things that are facing your external customers and they need that trust. Also code signing. So you need to ensure that your software is signed and delivered to your customers in a way that their devices and they can trust that it does come from you. So these public CAs, the challenge with them is that oftentimes they offer very limited certificate lifecycle management capabilities that are built into that, because by their nature, they're certificate issuers. The management component often is kind of where things are lacking. So if you're using multiple different CA vendors, it can create silos in certificate management and visibility. So what's really needed there is a CA agnostic approach where you can address those complex environments with a centralized inventory, and you're able to actually report on the status of those certificates. And then, of course, discovery. The CAs are one thing, understanding where those certificates are coming from, but there may be CAs there that you're not aware that are being used. Maybe Let's Encrypt, developers are leveraging that to issue certificates into your environment, and you're not aware of those. So you need the capability to discover those certificates where they are in different ways, things like network scanning or direct integrations with those key stores and certificate stores. And then lastly, of course, the automation, not just the requesting the certificates from those public CAs, but more so the deployment of the certificates and kind of what can go wrong in that direction when you pass that certificate off to an application owner. There's a lot of different mistakes that can happen there, including at the end of that certificate's lifecycle when it's perhaps forgotten to be renewed, and that of course leads to an outage. So a lot of the challenges around public CAs are getting that visibility and avoiding these kind of silos that get created. And then kind of under the same umbrella as public CAs, but more recent, I would say, is the free SSL TLS providers. And we've separated this out because they are essentially the same as a third-party CA service. They provide that trust, but at no or low cost. And these, again, are typically used for very similar use cases. Things like load balancers, web servers, but also in DevOps environments. These are very quick to procure and they're short-lived, typically 90 days. So example vendors would, of course, be Let's Encrypt, or Zero SSL is another one that we've seen in some environments as well. So the challenges here, the limitations that need to be considered are that at a basic level, only domain validated certificates are used here. So if your organization does have requirements for EV or OV certificates, that would kind of be a limitation here. And they're also not applicable for every use case in your environment. There's a lot more frequent configuration changes that are required for those 90-day certs. And in terms of integration and the content within those certificates can be limited as well. So you need to kind of consider those different things when leveraging these certificates. But the core thing here is just understanding where these things are being used. Again, a lot of the times these are very easy to procure from Let's Encrypt or Zero SSL, but less easy to understand where they are and monitor them throughout their life cycle. So you really need to, again, understand that visibility layer, but also in terms of automation, a little bit different with these free SSL providers who often support ACME. So ACME implementations are also supported by certificate management vendors like Keyfactor, and that's really important to be able to plug Let's Encrypt into a tool that's going to give you that visibility and that monitoring capability. But again, this is just another CA or a source of certificates that's being used in most organizations that we come across today. And then at a very core, the organization's root of trust really is the on-premise PKI or their private PKI. And this comes in the form of CA software and appliance, but it's really a lot more than that. These certificates are being issued for internal trust. So again, user and device authentication are very common. Web servers, authentication between those different web servers and applications, and DevOps and IoT use cases as well. But the challenge here is that, again, a lot of organizations rely on ADCS, but setting up and maintaining that private CA is a lot more complex than it initially seems. It's it's easy to click next and set up a Microsoft CA. It's a lot harder to ensure that that CA is really going to be a solid root of trust for your company. So not only that, but the ability to support scalability. The challenge with Microsoft CA is that you really can only deploy one CA per server. So you're stuck with a growing footprint of infrastructure that you have to manage as your use cases grow. And that's why we see organizations shifting to alternatives like PrimeKey EGBCA that's able to build an entire PKI hierarchy on a single instance. But that aside, the challenge here is really around the expertise and the hardware and software that's required to run this. Again, going back to those public CAs, that is their sole focus. They dedicate their infrastructure, their personnel to running a public root of trust really well. It's a lot harder to replicate that within your organization and often with limited IT resources and particularly with limited expertise in PKI specifically. So the challenge really is understanding that PKI is more than just machines and certificates. It's about a solid root of trust, things like your certificate policy and practice statement, the root signing ceremony, and then the configuration of policies and enrollment around that CA are really important to ensure that it's not only healthy from the start, but kind of maintained throughout its life cycle. And then, of course, same kind of principles apply as the previous CAs, is getting that inventory and reporting, the discovery of certificates across your environment, and then lastly, the automation. Again, auto-enrollment can serve some use cases, but there's a lot of use cases that aren't going to be able to be supported natively by the Microsoft server or CA. So you're going to have to look to other ways to be able to integrate that and automate certificates so that you don't have to leverage those manual processes. And then when we move to those built-in issuers, these are also privately trusted CAs or sources of certificates. And these are often short-lived certificates. They're being used, again, in built-in capabilities of secrets managers or service mesh or containerized tools. And the use case here is things like mutual TLS authentication, ingress, egress, and the security of the applications that run within those. Example vendors here are HashiCorp Vault. Ansible is a great example there as well. Istio, there's Citadel CA. A lot of these self-signed CAs don't provide a high level of assurance that organizations really need to ensure that those certificates are being trusted. So the important thing here is there's really two parts. There's one, making sure that, of course, you can use those self-signed CAs in certain environments where the trust requirements aren't as high. In those test environments. When it comes to production, that's where, of course, you need to be a lot more careful around the trust that sits behind those certificates. So do not use these tools blindly. Leverage them, of course. They're really fast and efficient for developers and engineers to use. But at the same time, ensure that there's a certain amount of trust sitting behind them, and at the same time that you're able to monitor what's actually being issued out of those and the ability to revoke certificates when they shouldn't have been issued in the first place. So the ability to integrate with both private and public CAs is really core to enabling those teams to get those certificates that are security approved, trusted, but at the same speed that they would leverage that tool without those integrations. So without that friction that they would often come across where they have to request a certificate directly from the PKI or the security team. Then as we move into the cloud, there's these cloud CA services. So these are private CAs that are being hosted and run by those public cloud providers. AWS Private CA and Google Cloud CA Service, which was just released within the past year. These are relatively new again. They do still require you, similar to an internal PKI, to configure and manage the CAs that sit behind them. Of course, the infrastructure behind it is off your hands, but the configuration around them is still very much on your team. So ensuring that you properly configure those root and issuing CAs is really critical, and centralizing, again, that visibility. Now, not only do you have silos between public and private trust on-prem and cloud, but even within the cloud, these different tools. You typically want to leverage the cloud-native tool within that environment. So you're not going to leverage AWS Certificate Manager Private CA for your Google Cloud environment. So ensuring that you have that consistent visibility is critical. So multi-CA support and multi-cloud support is a really core component there. And then integrations, again, being able to automate the issuance of those certificates. Many organizations will leverage certificate lifecycle automation tools to automate issuance of certificates, say, into Azure Key Vault. Microsoft Azure doesn't have a built-in private CA currently. That may change in the future, but the ability to issue certificates into that environment is also really important. So again, ensuring that you're really leveraging these different CAs in the right cases and not just kind of creating more CA sprawl is really important. And then, of course, going to the PKI as a service, these are managed and cloud-hosted private PKI services. So not to be confused with things like those cloud services, those cloud-based CAs. These include an offline route that is kind of protected and secured for you and established with that trust, but also with those issuing CAs that are hosted and managed for you in the cloud, so that you can get that scalable certificate issuance while maintaining that secure root of trust. And these, again, they're used for really a wider span of use cases. I didn't go as specific here. Really enterprise in those DevOps environments for highly scalable issuance, and then for IoT deployments. So if you're trying to embed a certificate onto a connected device, a core component of that is ensuring that it comes, again, from a trusted source. So example vendors are Keyfactor PKI as a service or PrimeKey EGBCA SaaS. These are both examples of how you can leverage more of a turnkey PKI model while still maintaining that level of trust and control that you need to report back to your security team so that they can approve the use of that tool. So consider whether you need a turnkey or a more hands-on PKI. For example, the Keyfactor PKI as a service is a totally turnkey, kind of zero-touch PKI. You really just access the certificates through the console and issue those, versus something like EGBCA SaaS, which is similarly a turnkey PKI, but you can still get your hands dirty in there and configure the CAs as you need them. So there are some differences there that you need to consider. There's a lot more solutions as well, but it's really important to understand that there are key differences between those. And then lastly, a core component of these is the certificate lifecycle automation. It's one thing to issue these certificates from a cloud-hosted PKI. It's another to manage them. So tools like Keyfactor PKI as a service actually include a internal CA that you can leverage for your organization, but also the certificate lifecycle automation capabilities to manage and provision those certificates where you need them to go. So having those tools both combined into a single platform is really beneficial for a lot of organizations. And then ensuring that you have control over the root keys and materials. Again, this is another key difference between some vendors. Being able to have that visibility into where the root keys are stored and the capability to take those back if you need to rebuild your PKI and move away from that vendor. That is something that's critical for the future and business continuity of your PKI. And then, of course, geo-redundancy and high availability, understanding where the root and issuing CAs are actually being hosted, and the ability to scale those up is really important as well. So we're left with, again, this decentralized PKI. There's plenty of reasons why you would want to leverage multiple different CAs. So going back to the Gartner quote earlier and kind of the continuation of that, they say to deploy multiple PKIs and CAs when you need them, but make sure to govern and monitor their usage. So that's kind of what we're going to get into now, is how do you plan your PKI deployment, whether you're starting from scratch or you're working with a PKI that's already in production. There's a lot of roadblocks that these IT and security professionals that are working with PKI come across. So we'll talk about those and then some of the key considerations that you need to make to upgrade or to improve your PKI for the future of the company. So first is the roadblocks to success. And we talked about a few of these along the route with the different CAs. And limited visibility, again, is really the core of the problem here when it comes to managing those machine identities. So it's extremely difficult to maintain visibility of those keys and certificates when users are self-provisioning. So a spreadsheet-based tracking might work at a very low scale, but as you move up, the self-provisioned certificates aren't going to be found in that spreadsheet. They're going to be found within your network somewhere that you don't know about. And when that certificate expires, you really won't know until that system goes down, and that becomes a problem that many of us are familiar with. Then there's the silos of control, which kind of ties into the visibility, but it also applies to configurations and the controls around those different CAs. When you're leveraging CAs in these different environments, the consoles and the controls behind them are all going to be different. So ensuring that you have consistency there is really important, and the integration between those. The inability to scale, again, that applies more to traditional on-prem PKI. Trying to meet the demands of modern cloud and DevOps requirements really is tough when you're leveraging an ADCS. Most organizations aren't able to make that work, and that's at the point where they think we need to use a new solution here. Lack of expertise, again, that goes back to the actual management of the policy and security and the infrastructure that sits behind a PKI. Setting that up is really complex, but also ensuring that when somebody leaves, that PKI is going to continue on in a state of secure operation. That's really difficult. We come across that quite a bit, where somebody leaves the organization and somebody comes in and has to take that role of PKI, don't really have any expertise in the area, and they're trying to figure this thing out. That's where a lot of things can happen, like configuration drift, where initially your PKI is set up really well with some robust security, but over time the configuration of that CA to meet certain use cases or just tinker with it here and there eventually leads to a PKI that's no longer secure for your organization. Limited automation, beyond visibility, you actually need to get these certificates where they need to go. And the effort to renew and provision and install those certificates can take a lot of time for your end users. Also, the requests on the PKI side, if you're getting certificate requests and overloaded with those, that takes a lot of time as well. And then when things go wrong, trying to troubleshoot some of those issues, like a misconfigured certificate, is really time-consuming for these teams. So there's a lot of inefficiency when you think about all these different tools and services that are creating these silos between different teams, but also cost efficiencies. Another example is that we see some organizations leveraging public certificates for cases where private trust is only needed. So there's a cost behind those public certificates, and they could be leveraging an internal CA to issue at scale, and that becomes very costly if you're leveraging public certificates across your entire environment as you start to scale up. So that's where we see a lot of organizations thinking we need an internal private PKI now to support that and consolidate a lot of these tools that we're using across different teams into a single root of trust and source of certificates for every team. So some of the challenges, again, when we go back to that state of machine identity management report, is just the growing use of these machine identities is creating an operational burden on the teams, again, both on the PKI and security side, and then on the application owner side. And they don't want to deal with certificates, they just know they need them. So they'd rather spend their time on tasks that they do day to day versus deploying and provisioning certificates. And then many organizations are also concerned about the increasing risk of key and certificate misconfiguration. Again, that's a very common issue. We've seen that with key rotation, for example, where a key was rotated mistakenly and it caused disruption across their infrastructure. And then organizations, again, going back to the visibility, they don't know how many keys and certificates they have. More than half of the companies that we surveyed in this Pwnymon report found that. So self-signed certificates and wildcard certificates are another key problem. And there's been a really great recent example of that. And I say great, outages are never great, but in this case, it really was, because Epic Games, what they did was they turned a bad situation into a lesson for really anyone who's working with PKI. So they actually wrote a blog about what happened when their systems went down for over 5 hours. And that, of course, upsetted a lot of their users. If you're familiar with Fortnite, there's a big fan base around that, and there's other games that they produce as well. But when these outages strike, they're typically unexpected. If you look on the right side there, we've seen a lot of them in the past little while with Microsoft Teams, Azure, Spotify, Google Voice, Google Wallet. There's been a lot of challenges there. So in this case, though, the TLS certificate expired. It halted traffic between their backend systems, and that created a downtime, an outage for their end users. Once the certificate was identified, which was pretty quickly, within 12 minutes, they were able to identify the root cause, that certificate, and started that renewal process. And then really within the hour, they were able to reissue that certificate and replace the expired one. But if you look into the details here, it took over 25 people that were directly involved to actually resolve this issue. In one point, they say that on a Zoom call, there were 25 people there. That's a lot of resources to pour into this outage response. But the bigger challenge here, and this is what we often see, is that this certificate is really just the start of the problem. So a certificate expires, but it kind of triggers this chain reaction. So in this case, when the systems went down, the traffic had to go somewhere. So it overloaded the requests that were going to their Epic Games launch services, and that actually brought those systems down as well. And eventually it took them, again, a little over 5 hours to fully recover from this outage. So the core problem here was a wildcard certificate. They were leveraging a wildcard certificate across multiple, in fact, hundreds of different production services. So that really expands the potential attack surface and outage impact associated with it if you're leveraging a single certificate across different systems and that certificate expires. But going back, they weren't actually actively monitoring that certificate on those systems, despite the fact that they were leveraging AWS Certificate Manager. And automated renewals were not something that was enabled at that time. Again, that's kind of something that in the mix of IT and security priorities tends to fall off, is the automation that's seen as a nice to have. But really, you run into situations like this when certificates aren't automated and the renewal is kind of missed, and then it leads to that expiration. So this is a really great example of what can happen when a certificate expires, and turn that into kind of a good situation, a lesson for all of us. So to wrap up, here's some key considerations when looking at this decentralized PKI model. So first is the trust requirements. So you really need to identify the right mix of public and private PKI that's going to be needed to support your web servers, your internal applications, things like securing email and Wi-Fi authentication, everything across the organization that leverages certificates. You need to identify whether public or private trust is required for that use case. And then going down, actually identifying all of those use cases in the first place. So different teams across the company are likely using PKI for different reasons and different tools. So you need to identify all those, bring those teams together, and understand what different types of integrations and protocols and automation would be needed to better support those different areas. Business continuity, again, this is a critical component. Consider how you're going to be able to handle those mergers and acquisitions or even divestitures. If a PKI suddenly you need to consume from a company that you've just merged with or a company you've acquired, that really creates a lot of challenges in trying to merge those trust chains. And then assurance levels. Where are those CAs located? What are the physical security controls on them? What are the access controls around them? And where are you using certificates in production versus test environments? Where is it okay to use self-signed certificates in a test environment versus production services where it's really critical? Required expertise, we've talked about that a bit, but determining if you actually have the right expertise and resources and the hardware that's actually needed to support this internal PKI deployment, especially if you're in a highly regulated industry, being able to reach the information security standards that are required for your company can be really difficult to achieve with internal resources. So kind of level setting on that and understanding where there are gaps is critical. And then maybe even most important of all for the kind of looking down the road is crypto agility. So preparing for the eventual migration to new algorithms. We saw that with SHA-1 to SHA-2. We still see a lot of SHA-1 certificates out there in organizations, but eventually SHA-2 will be in the same position and we'll be moving on to another algorithm. And making those moves can be highly disruptive if you don't have proper processes in place to identify and then replace those certificates. And also the ability to, going back to really the core of the topic here, is all of these different CAs, being able to add a CA into the mix or switch different CA vendors. Say you need to move from one public CA to another. Being able to do that easily can be challenging without a tool that automates that process. So bringing these CAs under one umbrella to have that centralized governance and control is really what we're after when it comes to decentralized PKI. All right, so that's it for today. If you want to learn more about this, we've got lots of great content. I encourage you to check out keyfactor.com. We've got white papers and blogs there that you can kind of dive a little bit deeper. Or, of course, we're always ready for a conversation. You just head over to our site and contact us there. We'd love to start that. So thanks again for joining us, and I'll be out for today.